Okay, I think I made the internet a worse place with that last video. I showed how to do the quadratic equation to solve for when it is at 42 meters. I'm going to do it now without the quadratic equation. Not going to be any easier, but it might be more clear. Maybe you don't like it, right? So here's 63 meters, right? And then the question is, when will it be at 42 meters? And our trick here is that we're actually going to Suvat this. And from the previous problem, we know that that initial velocity is 35.1576. Okay? Okay, we can't do the problem without that this way, without knowing that. And we got that from the first video on this problem, right? We did that solving it from here to here. Okay, and then I'm going to say that this is negative 9.81, right? That our displacement is 42. And now what I'll do, my strategy will be to solve for this guy. Okay, so let's do that first. So v squared is u squared plus 2as. So therefore, v is equal to, the absolute value of v is equal to the square root of 35.1576 squared plus 2 times negative 9.81 times 42. Okay, so let's try this. The square root of u squared plus 2 times negative 9.81 times 42. I'm going to store that in v. All right, I get 20.298. Okay? So my final velocity, so v is equal to positive 20.298 or negative 20.298. Okay? Let me see if I did this correctly. Yes, I did. Okay. So what that means is that, of course, the positive values for on the way up, the negative values for on the way down. So if we want to solve for the times, that is the time it passes the elevation on the way up and the time on the way down, we're going to use v equals u plus at, only we're going to do it twice. Okay? So let's see. Let's do this as going up. Right, the final velocity will be positive 20.298. Right, and then we'll do going down. Right, so the final velocity will be negative 20.298. Okay, so in both cases we'll just use v equals u plus at. So v is u plus at. Okay, so positive 20.298. This pen is so slow. Equals the initial velocity, so this guy 35.1576. Right, that's the velocity it has on the way up, plus negative 9.81 times t. Okay, there that is. Okay, so that divided by, whoops. I'm doing this wrong. Okay, here we go. Now we got it. Okay, divided by. So I'm solving that. I get 1.5147. Okay. Okay, so this I actually would say this is 1.51. I'm getting exactly what I got, by the way, with the quadratic equation, without the world like begging me to stop making the video. Okay, so there's that one, right? And then going down, right? So that's the second time it reaches, is it'll hit this más tarde, right? A little bit later. Okay, so let's set that guy up. V is u plus at. Wow, that pen's slow. Okay, so now it's negative 20.298. 0.298. I'm actually using a stored version of my calculator. Let's see. Equals positive 35.1576, right? And then that is plus negative 9.81. Got to write tall and thin, and then that's times t. Okay? And now when I solve this guy, I'm going to get a different number, right? And the reason why it's going to be a longer time is mathematically you're going to subtract this from both sides. That'll be a large negative number on this side. It will be a bigger time when you divide it by negative 9.81. Okay, so here we go. Okay. I'm actually just recalling these numbers from memory, but you would go negative 20.298 minus 35.1576 and get something like negative 55.4559. Then you divide that by negative 9.81. And I'm getting 5.65299 equals 5.65299. Okay, so I actually get something that would be 5.65 going down. Okay, so you can do it this way. You can use the quadratic. It doesn't really matter.